Okay. Hi, good afternoon, everyone. How are you guys doing? So today we gather here to talk about Overwatch. We will go about what led us to the development of Overwatch, the whole journey. So it's a super cool tool, which is like Google Maps for navigating the whole cloud infrastructure. So we will just get started with it, and we will start with some introductions. So hi, I'm Garvit. I'm a software engineer at Intuit. So if you guys pay any taxes, like any taxes at all, so $1 of that goes to me because I work for Intuit. And I recently graduated from Carnegie Mellon about roughly 2 years ago, and I love to be part of hackathons, develop, iterate, and develop some super cool products. I've been to a couple of hackathons like Hack Harvard, Yale, and it's just super fun, and I love that energy. Apart from that, in my free time now, since I'm from Bay Area, I have picked up the real sport, pickleball, and yeah, that's about my weekends. And now, Hemant.
Hey, hi everyone. So this is Hemant here, a staff software engineer from Intuit. So I visited more than 20 plus national parks. I like hiking, trekking. I'm from Colorado, Denver, so I like to go for hiking and trekking. I finished few of the 14ers there. So that's about me.
Okay, now I will take over. So I just want you to just squint your eyes and look at the screen and just try to figure out what is this data, what is this spreadsheet about? What do you think it represents? Right, you're right. It's like it's some data from a car, like car speed, what speed it is going at, like how much is the fuel level, what's the RPM. But why do you think is this better? Yeah, it's a yeah. So did you realize that in the previous spreadsheet, we were actually low on fuel. Now here you can see we are at 10% fuel. We would definitely run out, but it was much harder to see that. So if on a car dashboard, we would not have want a spreadsheet right in front in the like when we're driving. Why would we want something similar for our Kubernetes fleet? So this is essentially our motivation for developing this product. And yeah, this is definitely not how you would like your dashboard to look like, car dashboard to look like. And just in case you're curious, yes, it's generated with DALI, and I just inserted it last night. So now Hemant would be going over the problems which we were facing.
Yeah, so when you manage a large infra or a large number of clusters, so you have many problems, right? So like from the instance age or the AMI upgrades or all those security kind of things, how you can manage all those things, right? So that's basically the problem for us as well. We are running hundreds of clusters and thousands of instances, thousands of pods, thousands of namespaces in the Kubernetes space, right? So you need to be up to date on all the security stuff, and then when you can remediate, how we can remediate those security stuff, and again, it's a decision making, like when you want to upgrade your clusters and how you can make your fleet is up to date, right? So all those, like, we were having numerous problems, like how we can manage all those things at a go. Uh, then we come up with the solution kind of a thing. So wherein, can you go to the next one? So, so solution on the solution of those things, right? So we have numerous data, right? So those all across the systems. So we created the batch job, like which can take all the data from the different sources, massage that data, put it in the proper format, and push it somewhere, and then build a cool dashboard, like Garvit was showing some time back, like on the car, right? Like how you can see when you are running out of the fuel. And that's what we did. Like, okay, get that data, massage it, push it at some place, and then build cool dashboards on that. So you can, on a click, you can see like, okay, how your infrastructure is, where are the problems, and before you get to those security issues, how you can remediate. So you will be up to date on all those things, right? And also it helps for your capacity planning because your infra is growing day by day, right? Because you get new workloads on your clusters, your infra needs to be capable of accepting those workloads. So how you can manage, right? So with this, we are like, with this our dashboard, we predict that like, okay, so our infra is growing at this percent. So how we can match that infra with the additional capacity. Again, like when we put those resources, right? The another challenge in the cloud space is like, okay, the cost. So you have a lot of wastages. So with this, you can say like, okay, my clusters are growing this capacity, with this capacity, and what are the wastages on those, and how I can minimize those wastages, how efficiently I can use those resources, right? So we can take those things with the Overwatch as well, right? And it also, it tracks all kind of metrics. It's again tracks all kind of instances, what fleet is working on which kind of infra, all those it captures. Okay, can you go to the next one, please?
Okay, now I know you have been seeing a lot of text, so I will show you some more text, but I promise a pretty looking dashboard is coming soon. So I will just go over the stage one of the iteration and basically what were the features of the dashboard. So we needed a couple of things, like there were key problems which we wanted to solve for. So like one of the main things which we wanted information is about basically our distribution of clusters over various regions. How like what is the generation of our instances which are running, region-wise distribution of the AMIs, and like the basically the architecture of our whole infrastructure. So we collected all this information, represented in a nice graphical format, so it is much more easier for it to digest and basically drive insight and take some decisions. So I will basically now go over how Overwatch basically exceeded our expectation, and all it, and we are actually using it much more than as we are at more than we expected. So all the data which we got from multiple sources, we kind of we kind of put it on a dashboard. So I will just go from left to right, where here you can see, okay, let's say I have to for compliance purposes, we have to stay within certain range for our AMI age. So if I want to know, okay, in next 30 days, I'm going to run out of this specific date, what I can do is, okay, put 30, 50 and click on the button, and all the data would get modified right on the go. So now I exactly know what instances should I rotate, which clusters are being problematic, and so on. Then let's say if my instance has been like launched for quite a while and it has been like more than 25 days, boop, I click the button, I know, okay, this is going to run out, and it has to be within our security limits. Then if you see about the cost optimization perspective, like if you have used Amazon Web Services or like any cloud infrastructure at all, there would be certain instances where the they would have terminated the instance, but it would still show terminating, but it never terminated. But there's a cost associated with it. So we noticed that there was many times this was happening. So we can decide basically a duration. Okay, let's say if the instance does not terminate within 30 minutes, then it means that it's pretty much in a stuck state, and basically we can send that data to AWS and get money back for it. And we are talking about 5-7 instances, it probably does not matter. But when we're talking about 20,000 plus instances and this happens regularly, then probably you're like talking about hundreds of thousands of dollars in the long run. So that's a very key metric. And this dashboard also helped us with migration of our instances. For example, at the top you can see Gen 5 and Gen 6. So for cost perspective and performance perspective, we basically migrate our instances, and this comes very handy to track, okay, these are the instances which have been migrated, this is the stage, this is our pending work, this is our architecture, and so on. And similarly for the GP2, GP3 volumes as well. So it's just you make the click and you get all the data right in one go. Now this was actually very useful for us. But now there was stage two. There was one lacking part. There was one specific improvement which we specifically wanted to make. That was that, okay, we have the current data about our infrastructure. But one more thing which we wanted to have make the use of real data was historical comparison. We wanted to see how our infrastructure is growing over time. Let's say if a tax peak is coming, because none of you file your taxes on time, you wait for the last day. So definitely we want to scale, or we want to definitely want to scale at the right time, at the right moment. And since we will have some historical data, we will be able to predict right in time, okay, this is the capacity which we want at that during the particular peaks. So with historical data, we came up with a minor improvement. It's pretty much the same dashboard. I know it's blurred out, but it's pretty much the same data. What you can do is you see a date field. You can basically choose a specific date, and it would basically show you data for that particular date. And now you can see the comparison, how you're growing, shrinking, make predictions, and basically pretty much like it eases the whole process of like not making a ballpark figure in the future, just relying on some real data which is from the past and come out to be very useful. Now Hemant would be talking about how we are actually using VMware and how it's actually helping us.
Yeah. So what are metrics we get, right? So most of the metrics we push it to the wavefront, like from different components, and then based on those metrics, we build some charts, and then see what how is our cluster health, or the how is the our cluster capacities, where we are using how many instances, and what kind of instances. That data we get it on the wavefront. So that data, what we do is like wavefront. We push that data to wavefront, those metrics, and also for the Overwatch to make sure we are on the right track with the all the points what we get. We compare that data with the wavefront, and we also consume some of the data from the wavefront, and that enriches our wavefront dashboard. So this is some of the example, like what kind of data we get it from the wavefront, so which makes sense to us, right? So number of active nodes, or the CPU utilization, memory utilization, cluster memory usage, and what capacity are they are. So I will briefly go over the architecture. Like it's not too complicated. Like we have a different system, different sources from where we are pulling the data. So it is fairly simple. Like we have we get all the metadata from the Amazon EC2. So we are on AWS fleet, most of the our clusters. Then we get some data from the wavefront, some of the metrics, key metrics, which are related to the instances. We have our own Kubernetes service, Intuit Kubernetes service. It's called as the IKS. We connect to the IKS to get all the clusters, whatever are the clusters are there, what accounts they are in, and we have the AMI data, wherein when that AMI is created, when it's due for the next renewal, and all those things. So all this data, we have it in the raw format. Earlier, we used to, get that. We have to go to different resources to see like where my cluster stands with perspective of the security and compliance, right? So we used to do that manually. So what we did, we wrote a Python library which gets all the data from all different sources. It matches all those data. We flatten that data and then push it to the data lake. So why we are pushing it to data lake? So if somebody in the company or other teams, right, they need to use that kind of data, they can use that data from the data lake. So we created one extra stream for the others to use that one. And on that data lake, right, so we built the Overwatch as a nice dashboard, like what Garvit showed some time back, to get all that data and build all the dashboard what we need for all our use cases. And the same data can be used for the other teams as well for their different use cases. This is fairly, it's not that complicated architecture. It's just simple Python library, getting all the data, massage that data, put it in the proper format, push it to data lake, and build a dashboard. And then data lake, why the data lake there, right? So again, I said like flattening data, pushing it so other can take the advantage of it. And then if you want to do the historical comparison, right? So we need to have some source where we can see like, okay, yesterday, how was my cluster capacity and how is today, or the when was the last time, what was the peak, and during the tax season. So we need to make sure like our capacity is at par, and then we compare that. Okay, last tax season peak time, what was the capacity, right? And then you can compare that data, and then ahead of the peak, you can just bump up your capacity on those clusters and get going, right? So that's about the architecture. Next one is the Garvit will go over the benefits.
Yeah, so we have pretty much talked about benefits, but there's one particular thing which I would like to highlight. I know it automates stuff, it streamlines the whole operations. There's historical data. You get to see everything out of place. And of course, it's like a dashboard for your whole Kubernetes fleet. But the last point, 100% compliance. When we did not have the Overwatch dashboard, we were nowhere near even in compliance. Like forget about 100% compliance. So with just a better view and like the key things which we wanted to focus on, like AMI age, determination duration, we we were able to see well in advance what is coming on our plate and basically able to assign the request to the right people or take care of it well in time. And this is the perfect place where we think Overwatch has given us the most value for our buck is 100% compliance. And yeah, there are a few improvements in our mind, definitely, because now that we are done with the stage one and stage two. uh, Stage two was having the historical data on the plate. We are not just static. We can see, okay, based on the past, we want to make some improvements. So for our next steps, we want to add some more specific metrics which could be related to our related to cluster upgrades, because there's tons of decisions which we still make for our cluster upgrades based on this dashboard. So it would be nice to have some pertinent data related to that, and we can make those key decisions. And one another area which we would want to focus on is basically cost saving opportunities, especially like checking out the auto scaling groups and how well provisioned, if we are running over capacity, how we can just trim down and stay within the limits. And this will definitely get better as we have more data and we are able to see more patterns. The second improvement which we want to make is basically the all the UI which you saw was based on ClickSense. So this ClickSense UI was really helpful in for us in putting up all the metrics really quickly on the go. Like we within a month we had like from nothing to a very well functioning UI, and it was just possible because we had the flexibility of ClickSense. It's like drag and drop. But now that we know what we want and we know where we want to improve, it would be much better to have a flexible UI which can be like a React UI where we can use some custom components and basically make it much more responsive. And as our data grows, we are already feeling that with the historical data, it's already slowing down. So this is the next step which we are actually working on. It's in progress, and hopefully next time when you come and visit us, we will have a React UI. And now we are open for question and answers. If you have any questions, feel free to ask. Yeah.
Using machine learning or AI to help you with the predictive nature of issues.
Yeah, so as we have this all data, right, and we want to predict those things for a number of occasions, right, like the when the peak and all those things. So we are working on the, using the AI and machine learning to predict that one. So we already in process of that, and it's we will be launching that in next month, mid of next month. where we have a good result as just the, we don't want to over budget our capacity or very low as well, right? But right now it's giving like 5% plus or minus. So that's the results we are getting right now.
And actually the interesting part is that at Intuit we get like a week where we can iterate and basically play around with anything you want. So it's like a week of you choose the project, you choose the field, just do whatever you want. Just it's like it's like 5 days of hackathon. So the project which we actually worked on was like how we can use machine learning algorithms for predicting the capacity. If you guys don't have any other questions, yeah, then that was our session.
Okay. She has one.
Oh, okay. Sorry. Go ahead.
So, ready? Okay. So, is Click part of your stack? And that's what you guys are using to make all this magic happen? Or is Click a requirement of the maps, of the environments you're trying to make maps up? Are y'all using Click?
Yeah, we are using Click. So it's basically a representation of all the data which we have, and you can use anything. Like you can also maybe use Tableau, or you can also create your own React dashboard, or maybe like make it part of the ilk stack and get some even finer details. So we are using Click because it's really fast and quick to iterate and make the changes, but it's just an idea. Use
Right,
whatever
so-
you like.
But so, like, if somebody else wanted to use your product, they wouldn't need Click. They could just use your product, and Click's part of your stack.
Yeah.
Right. Okay. Got it.
It's just the UI stuff, right? So data is there, it's already flattened, so you just build any kind of a UI, whatever you want, right? Yeah.
Awesome. Thank you. And don't forget to connect with us on LinkedIn. Thank you.
Yeah.
Presentation, guys.